Greetings, M squared here, and today our goal is to identify linear functions. So that's pretty easy if you know that a linear function, if you know that the first four letters spell the word line, most people can figure out what a line is. This is a linear function. It's a line. The only kind of functions that are not linear are vertical lines. So pretty much any line except a vertical line is going to be a linear function. So if it's a graph, it's pretty easy to tell. Then comes the table and equations. Those are a little bit more challenging. So remember, a linear function, sometimes we learned y equals mx plus b. F of x, remember, is just y in disguise. It's just the name of the function is f, and that's our input or our variable. The m and the b actually stand for numbers. That's the slope, and that's the y-intercept. So your job is to be able to find out if it's a linear function, if I give you a graph, if I give you a table, or if I give you an equation. All three of those. So we're going to do them separately. So let's talk about the equation. The equation will have an f of x or a y, and it will have an x. It will never have an x squared. It will never have a square root of x, absolute value of x, just kind of this form. It doesn't have to have a b, doesn't have to have an m. Well, you know, it could be 1. So you could have like y equals x. You could have f of x equals 1/2 y plus 2. Sorry, how about an x there? F of x equals 1/2 x plus 2. So any equation that kind of has this form where it's just an x is going to be linear. When it comes to the table, we want to see if the rate's the same. So we're starting off easy. What we want to do is just kind of ask ourselves, how do you get from one x to the next x? So from here to here, what would you have to do? You'd add 1. And from here to here, we see that again, it's add 1, add 1, add 1. So each time on the x, we're adding 1. Remember, a line has a constant rate. It's a constant rate. So if this wasn't the same each time, then we want to make sure that this kind of mimicked whatever this did in a way. Okay, I shouldn't say mimic. I mean, so it should be the same. So let's talk about this. There's minus 2, minus 2, minus 2, minus 2. If this goes up by 1 each time, then whatever happens between these two has to happen the same. If this went up by 2 each time, then this would have to be the same. We aren't going to do the tricky kind when it's not in order and it's not the same distance. So we'll save that for another time. But for right now, I'm going to give you basic, simple ones. So we just want to make sure that the rate's the same. For those of you who are at like a little advanced level, remember that the slope is the change of y over the change of x. So even if this was a sporadic, not consistent kind of distance, then you could always do the change in y over the change in x and make sure that that's the same every time. That difference of, the change in y over the change in x, that slope. So for right now, the slope would be negative 2 over 1. So that's kind of for an advanced level. You wouldn't need as many nice, pretty ones. Okay, so what kind of lines are not functions? And I kind of already said that. Vertical lines are not functions. Any other line is going to be a function. Okay, so now it's our time to practice. Never mind, I gave it to you, linear and non-linear. So these are examples of linears. These are examples of not linears. So remember, I said it has to have an x. So here's our x. The slope is 2. Here's an x. Our slope is negative 4. Our y-intercept is 8. Our slope is negative 1, 4. Our y-intercept is 6. And here it looks a little bit different, but it's still linear because I could change this into x over 5 plus 3 over 5, which would mean my slope is 1/5 because it's x times 1/5. It would be the same as x over 5. And my y-intercept would be 3/5. So anytime you have that consistent pattern, it's a line. So things that tell me these aren't lines. Here's what tells me that's not a line. That's a squared. Linear functions do not have squared. Absolute value. Linear functions do not have absolute values. An x as an exponent. Linear functions don't have that. That kind of looks like this. An absolute value is a v. This is a parabola. So knowing what they look like can really help you. This right here would be a cubic function. The cubed tells me it's not linear. So you might not know what all those look like, but it's important to notice that they have something different than these. These are all lines like this. Okay, linear functions, nonlinear functions. Again, parabola, absolute value. Okay, let's practice. So if you see a picture, you should be able to do it an equation, hopefully you can do it. Let's talk about how we can do it if it's in the table, because I think that one usually is the most challenging. So we're going to first find the difference between the x's, then we'll find the difference between the y's. So again, plus 1, plus 1, plus 1, plus 1. We want to make sure that's the same. And then we want to make sure this is the same. So if that's plus 3, I'm thinking, oh, can I get 3 here? Yep. That's plus 3. Do I get plus 3 again? Yes, I do. If I do each time, then that's linear. I know it's linear because that rate, the constant rate of change. Remember, a linear function has a constant rate of change. So y is changing, x is changing, they're each changing with each other. Up over 1, up 3 kind of thing. Okay, let's try this one. So here we're going to go up 2, up 2, up 2. So we're going plus 1, plus 1, plus 1. So yes, it is linear. Okay, last example. We see a plus 1, plus 1, plus 1. And then here we see a minus 4. And here we see a minus 4. And here we see a minus 4. So is it linear? Yes, because each time we had that same thing happening in the top and the bottom. That is what makes it linear. So if one of these was different and it changed it, like let's say that was a -8, then that would have changed our pattern and we wouldn't have seen the -4 each time, and that would have made it non-linear. So keep that in mind as you're doing your homework, because some of them will not be linear. We want to make sure you know how to find a linear function. Okay, good luck with that. N squared, sin and